The sea has no mercy. These young men are Russian sailors. Within a year, they would all be dead. On the 12th of August 2000, a massive explosion thundered under the Arctic Circle. The Kursk, a giant Russian submarine, is torn apart and crashes to the bottom of the Barents Sea. For 10 days, the Russian Navy tried to make contact. The LR-5, one of the most advanced rescue submersibles in the world, contracted to Britain's Royal Navy, is called to the site. But it's too late. All 118 hands are lost. The ocean is an extreme and hostile environment. We know more about the moon than we do about the deep. Submarines are the ultimate extreme machines. But what happens when something goes wrong? When a submarine sinks? And why is submarine escape so difficult? To find out, we followed Operation Satchel, the submarine rescue exercise staged every 5 years by NATO off the coast of Scotland. The principal players, the most advanced submarine rescue craft in the world, the US Navy's Mystic and the British Navy's LR-5. It's 100 years since the first submarines were introduced into the British and American navies. Sailors called the first submarine fleets the coffin service. In World War II, submarines played a new and critical role. Winston Churchill said, "Of all servicemen, none face more terrible dangers than the submariners." All told, almost 100,000 of them were lost at sea. Escape equipment and training were crude. In battle, rescue was never really an option. But in peacetime, loss of life was unacceptable. On a freezing night in January 1950, HMS Truculent, with 79 crew aboard, collided with an oil tanker in the Thames estuary. Truculent flooded, and in a minute sank 75 feet down, trapping her crew. Few survived. One of the few was Les Stickland.
Just before 7 o'clock, the engines stopped, and almost immediately we had an enormous impact. The boat heeled very, very sharply to port, and realizing something was drastically wrong, we made our way out of the mess, and I went to my emergency station, which was the control room. I was responsible for the diving and surfacing equipment and operation of it. I blew the tanks, trying to keep the bows up and the boat on a level keel. Very shortly after this, water got into the batteries and the batteries shorted. We were treated to a marvelous pyrotechnic display for a few moments, and then darkness.
It's almost impossible to imagine the terror. The hull breached, seawater thundering in, fighting to close watertight hatches. Inside the Truculent, the concentration of exhaled carbon dioxide was becoming dangerous.
It kicks you out. You can't remember what you're doing and can't think straight. And we were terrified that if we hung on, then we would be affected by carbon dioxide poisoning and the whole escape would go sour. We could hear propeller noises above us, which we assumed, wrongly as it turned out, were the rescue boats waiting for us to come up. In point of fact, our biggest concern was the fact that we might come up underneath one of the propellers. we thought about that and decided, well, we'd have to take that chance.
The truculent crew knew their air supply would not last long. Inside the escape chamber, the crew pulled down the canvas trunk to the escape hatch. They opened the flood valves and seawater filled the chamber. Once the pressure inside the chamber equaled the pressure outside the hull, the escape hatch could be opened. One by one, they climbed into the trunk and kicked off to the surface, into the unknown. The desperate measure of making a free ascent is still an essential part of training. Today at Fort Blockhouse, Royal Navy submariners are taught to make a free ascent in a 10-story tower of water. At the base of the tower, the trainee submariners breathe in compressed air. As they ascend, they must exhale continuously as the air in their lungs expands. Hold your breath, your lungs will burst. But for the truculent survivors, there was another hazard.
No problems at all on the escape until I got to within a few feet of the surface. And it suddenly occurred to me that I'd been breathing out a lot. There was no pressure left on my lungs. And I felt that I must have breathed out too quickly and was not going to make it. But just about the same time as I realised this, then I broke the surface. And the feeling of euphoria as you breathe fresh air again was fantastic. And for the first few minutes, you're shouting, laughing, and happy as Samboy. And then suddenly you realise that there's nothing there, no one to pick us up. It was a bitterly cold night. The water temperature was 1 degree above freezing. And very shortly after that, friends started disappearing, shouting, crying, screaming.
The truculent crewmen did not last long in the freezing water of the Thames. There were just 10 survivors.
So far as I know, it's the first and only time that the whole crew of a submarine have escaped in their entirety. And for this we felt quite proud. The tragedy, of course, was that having escaped, very few were picked up.
Losing so many men on the surface forced the British Navy to design a new kind of survival suit that would save lives. Today, the British-designed Beaufort Mark 10 is the state-of-the-art survival suit. The hood fills with compressed air in the rescue chamber and allows free ascent from 600 feet, pulling the submariner to the surface at 3 meters a second. Northwest Scotland, Operation Sedgemoor, Day 1. The rescue exercise begins in earnest. The Royal Navy Submarine Parachute Assistance Group simulates a surface rescue. An RAF Nimrod picks up the SOS and GPS signal from the submarine indicator buoy. Submariners put on survival suits, watertight, thermally insulated, and with a built-in life raft. The Mark 10 gives submariners a fighting chance, keeping them alive on the sea surface, long enough to be picked up.
Before you put in the water, right, you are to ensure that your gags are up, your stowl is fully inflated. Right.
As the training team wait on the water, the parachute rescue team swings into action.
Our primary method of supporting this sort of operation is actually rescue rather than escape. The escape part of it is very much the last line of defence we have in this sort of area. These sea conditions are fairly benign at the moment. Clearly in the middle of the ocean we can't predict the weather, and it may be the weather is particularly bad, in which case your chances of survival get worse rather than better.
60% of the world's oceans are over 5,000 feet deep. Submarines have a maximum dive range of 1,000 feet, where water pressure is 1/4 of a ton per square inch. Beyond, they'll be crushed. It is every submariner's worst nightmare. A systems failure, an onboard explosion or collision, a breach in the hull.
We believe that the majority of your accidents are going to happen on the continental shelf, which we assume to be 200 meters or less, and our rescue vehicles are clearly capable of getting down to that depth.
Sedgemoor, Day 2. The US Navy rescue vehicle Mystic is unloaded at Glasgow Airport. Sedgemoor moves into the principal rescue phase of the operation. British and American command transfers to the Swedish support ship Bellos. On deck, the British rescue submarine LR5.
LR5 is the rescue submersible that we use and exercise with, so that in the event of a submarine accident, we are ready to go down to that submarine and to rescue anybody that has survived whatever the accident was that caused them to be on the bottom. We have used this rescue submersible for best part of 20 years now, and have adapted it and modified it so that it's now one of the finest rescue vehicles in the world. Totally flexible, air transportable and very manoeuvrable.
The LR5 started life not in submarine rescue but in the North Sea oil business. Designed, built and owned by commercial operators Rumik, she's now contracted full-time to Royal Navy Submarine Rescue. The LR5's home base is on the Clyde in Scotland.
On the front here we've got our bumper bar, which protects the front of L5. As you can see, it's damped. And moving further up, we have our tow hook, tow beam, and above that we have our pinger receiver. What we would do is, when we find the submarine, we place a pinger on the submarine. This is a 27 kilohertz beacon which bangs away once every second. As we turn on to the heading, the noise increases until it reaches maximum, then dies off. We then have a heading. I then find it on my sonar, which is above that. If you can just see above there, there is a sonar head.
Built from steel, reinforced glass fibre and acrylic, LR5 can operate down to 1,500 feet. Joints and seals are tested to withstand an outside water pressure of 1,000 pounds per square inch. Powered by lead-acid batteries, she has a maximum speed of 4.5 knots. The plexiglass viewport is 1 centimetre thick. Underneath the craft, the number 1 hatch and a surrounding steel docking skirt. The LR5 can rescue 17 crew at a time. Survival kits are ready for each rescuee.
Okay, the first thing we've got in here is lithium hydroxide, which allows the CO2 to be scrubbed from the atmosphere. It is fitted with an oral nasal mask. Both ends are removed and it has its own filters. This is then placed over the top, and the oral nasal mask is used, and it's just a lung-powered scrubber. This is used in an emergency should the life support fail, or we're down longer than our 24-hour dive.
Day 3, Sedgemoor. The US Navy Mystic arrives at Coulport Submarine Base. There, she is mounted onto the back of the mother submarine HMS Vanguard. The focus of the exercise will be to rescue sailors from the Swedish submarine Gotland. Simulating a distressed submarine, she'll rest on the sea floor. The task of the rescue craft will be threefold: locate, lock on, and liberate the stranded sailors from the Gotland. The Mystic is the veteran of submarine rescue vehicles. Constructed of 3 steel spheres within a fiberglass skin, she has a maximum operating depth of 5,000 feet. The Mystic story begins in the Cold War. A series of submarine disasters forced the US Navy to look anew at their rescue capabilities. In April 1963, the US sub Thresher sank on Atlantic sea trials. All 129 hands were lost. In the wake of the Cuban Missile Crisis, the Soviet Navy began regular Atlantic patrols. US submarines monitored Soviet missile tests. If fragments could be picked up from the ocean floor, then maybe Soviet nuclear capability could be assessed. Space program scientists were commissioned to design a new craft that would not only rescue trapped submariners, but also gather strategic intelligence. In 1971, the Mystic was launched. Today, her primary mission is humanitarian, saving the lives of submariners of any nationality. Mystic's home port is at the Deep Submergence Unit, US Naval Base San Diego. Mystic and her crew exercised regularly off the California coast. "15 meters long and weighing 38 tons, she has a crew of 4 and places for 22 rescuees. The standard training dive is to deep seat, a fixed mating plate 2,000 feet down, far beyond the range of any conventional submarine. Her technology is constantly modified and updated.
This here is actually the transfer skirt. This is the part that mates to the submarine. Underneath, it's just a metal-on-metal contact, and there's a big rubber O-ring under here. What will happen is the DSRV will come down onto the contact and will actually land on this shock ring. This shock ring actually lifts up to about here, then you'll be sitting on the skirt. This right here is the main propeller. Puts out about 15 horsepower at 800 revolutions per minute. Gives us our hair-raising top speed of 4.5 knots. Just DSRV-1. What we have here is a simple styrofoam coffee cup, and it's going to go down to 2,000 feet inside the canopy on top of the vehicle. And due to the sea pressure, it won't actually crush it and waste it into oblivion, but it'll actually shrink it so it's about that tall and a little bit narrow. DSRV-1 and the dive number 1027, and we'll take a look at it when you come back up.
The Mystic is lowered into the water from the support ship.
When we go to dive, the pilot's going to pitch the vehicle up, probably about a 40-degree angle, and we're going to back down. He may want all of us to go to the atmosphere. If he does, we'll all go back there.
Before they dive, they pitch and roll the craft, shaking out air bubbles from inside the fiberglass skin. At a steady 4 knots, she dives down to the mating plate.
This little white square in the middle represents the DSRV, where we're at, and it displays our heading, which direction we're pointed in. We can get a contact off our sonar system, and from that it'll give us a bearing in yards and a range, or bearing in degrees and a range in yards. This is the forward search mode over here. It's good to about 8,000 yards.
At 2,000 feet, the outside water pressure on the hull is almost half a ton per square inch. Gently, the pilot rests the Mystic on the mating plate. Inside, the temperature approaches freezing. Outside the craft, darkness.
Being underwater is it's a very hostile environment for humans and even crafts like this to be in. And it's just a feat of engineering for us to go down to 5,000 feet and explore, or even to 2,000 feet, just to hang out and explore down there. But not to lose focus, our primary job is submarine rescue. And though it's never happened, and hopefully it never will, we're here just in case.
Returning to the surface, support divers pull the lifting frame beneath the craft. Mark Nagornik showed us what 2,000 feet of pressure does to a coffee cup.
This is our little friend, the styrofoam cup that started off as a full-size coffee cup. And this is what about 880 pounds per square inch of sea pressure does to a styrofoam coffee cup right here. Same exact cup, same writing. We didn't alter it in any way except its size.
Back in Scotland, Sedgemoor continues. The LR5 rolls down the deck of the Bellos into position. The final phase of the rescue exercise begins. Aboard the Gotland, the captain gives the order to dive. LR5 is lowered into the water.
Depth now, 30 feet, going off comms on pinger search, over.
Search sonar locks onto the Gotland distress signal, and at a steady 4 knots, LR5 makes her way down. Conditions match the Kursk scenario. Sea temperature is just above freezing. There is a 3-knot cross current. 300 feet down, LR5 approaches the Gotland. The Swedish Navy crest is clearly visible from the viewport. Working her way aft, the LR5 moves towards the escape hatch. The LR5 rests gently on the escape hatch, making a soft seal. As water is drained from the LR5 skirt beneath, the outside water pressure, over ½ a ton per square inch, holds her to the Gotland, making a hard seal. The pressure between them is equalized, and the LR5 hatch is opened. A crewman checks the seals to make sure no water is seeping in.
Sail good.
The first Swedish sailors climb the Gotland escape tower up to the LR5. Success. On the 4th day of the exercise, HMS Vanguard and the Mystic start their phase of the rescue program. For the next 6 days, the rescue craft perform another 20 successful dives. The British and the Russian navies have now started a close dialogue. There is talk of a joint exercise, just like Sedgemoor, in the future.
We're developing a very close relationship in the area of submarine escape and rescue with the Russian Federation. They have some very similar ideas. The design of their submarines are very similar. There are some subtle differences in philosophy, but we're keen to share information because escape, rescue, safety, saving lives at sea are areas that we can afford to be very open and honest. Because if there's any submarine accident in any country, then we would all offer our help and assistance and assets as freely as we could do.
The Kursk disaster was a wake-up call to submarine rescue services around the world. Had a coordinated international rescue effort arrived in the Barents Sea in time, would the lives of the Kursk sailors have been saved? Could the LR5 and the Mystic have saved the lives of 118 Russian sailors? Today, the goal is to give every submariner of any nationality the chance of survival, should the unthinkable happen.